Good afternoon. So we move on to second problem. A 3-hinged symmetrical parabolic arch, 30 meters span at central rise of 5 meter, subjected to point load of 80 kilonewton at 10 meter from the left hinge. So we have to compute bending moment diagram, normal thrust and radial shear at 12 meter from the left hinge. So please try to take the diagram. So, 3-hinged parabolic arch. It's a symmetrical 3-hinged parabolic arch. It's a crown A, B, C. So having a span of 30 meter, therefore the span A to B is 30 meter and a central rise of 5 meter. Central rise, this is the central rise. Central rise is 5 meters, subjected to point load of 80 kilonewton at 10 meter from left hinge. So very important. So it's a right hinge, it's a left hinge. So this particular load of 80 kilonewton is subjected from 10 meter from left hinge. 80 kilonewton. So distance of 10 meters from left hinge. So this is the given 3-hinged symmetrical parabolic arch. We have to determine bending moment, normal thrust and radial shear at 12 meter from the left hinge. So it's a general procedure. The very first step is determination of external support reaction. So here we are having two external hinge support. What are the reactions at hinges? VA, HA. There are two reactions, VB and HB. VB and HB. So initially we are going to determine the external support reactions. That is VA, HA, VB, HB. So the very first step is determination of external support reactions. Apply sigma Fy equals 0. The general sign convention is upward forces are treated as positive, downward forces are treated as negative. So you just apply to this particular section plus VA minus 80 plus VB. Only 3 vertical forces, right? There are only 3 vertical forces, plus VA minus 80 plus VB. Therefore, VA plus VB, that is equal to 80. Say equation number 1. Next, you take sigma moment at A equals 0. You are taking sigma moment at A equals 0. If you take sigma moment at A equals 0, HA, HB and VA will not come into picture. Why? Because those 3 forces act at same line of action, same point, right? Therefore, this 80 moving in downward direction, because of this 10, take a turn clockwise. Therefore, 80 into 10. 80 into 10. Next, this is 0. VB moving in upward direction because of this span 30 meter. It take a turn anti-clockwise direction. Anti-clockwise direction minus VB into 30 equals 0. Now 800 equals 30 VB. So what is the value of VB?
26.67 kilonewton.
26.67 kilonewton. Is 800 by 30. We are getting 26.67 kilonewton. Now substitute this value in equation number 1. We are getting VA. So VA equals 80 minus VB. 80 minus 26.67 So what is the value of VA?
53.33.
53.33 kilonewton. See, we got VA value and VB value. Now how to determine HB or HA? If you take sigma Fx equals 0, for this all right side forces are acting positive, left side forces are negative, then we are getting HA plus HB equals 0. Because of symmetry, both HA and HB values are same. There is no inclined forces on the arch. There is no inclined forces on the arch. Therefore, HA equals minus HB. The value equal to H. HA equals minus HB equals H. For the determination of H value, we have to take moment at crown. Whether you have to take right side or left side, any one part you have to consider for the analysis. If you take right side, sigma MC equals 0. If you take RHS, there are only two forces coming to picture. VB rotating anti-clockwise direction as well as HB also rotating in anti-clockwise direction. Therefore, minus VB into L by 2, that is 15, minus HB into rise. What is the rise? That is 5 equals 0. Therefore, we are getting 5 HB, which is equal to, the value of VB is 26.67. So minus 26.67 into 15. So compute the value of HB. What is the value of HB?
80 kilonewton.
Minus 80 kilonewton. Minus 80 kilonewton. The HP value is minus 80 kilonewton. HA 80 H. That is nothing but we have to reverse the direction. The HB we have to reverse the direction. So this is 80 kilonewton. This is also 80 kilonewton. Because if you take HB equal minus 80, minus into minus plus 80, HA will become plus 80. And VA value is, we are having VA value as 53.33 kilonewton. We are having VB value as 26.67 kilonewton. This concludes the first step, determination of external support reaction. Now we move on to second step. So the ultimate aim of the problem is to determine the bending moment. Normal thrust, radial shear. For the determination of radial shear and normal thrust, bending moment, we require some values, because it's asking to determine a 12 meter. 12 meter matlab here somewhere it comes. So I don't know the value of y and all. X. I know x. He's given x value, horizontal distance, right? So for the thing in second step, we are computing rise equation as well as slope equation. We know equation of parabola. Equation of parabola is given by 4hx into L minus x divided by L square. 4hx by L square into L minus x. So it will become 4. I know rise. H is the rise. 4 into 5 into x divided by L square. That is 30 square into 30 minus x. Now we just simplify this equation. We are getting equation for parabola. Y equals
0.667x
0.667x
minus
0.022
x square.
x square. Just simplify this equation. 20 divided by 30 square into 30, it will become 0.667, and 20 divided by 30 square will become 0.022 x into x square. So take this as equation number 2. Now you differentiate this equation. This equation is called Rice equation. This is Rice equation. If you differentiate this equation, you are getting dy by dx equals 0.667 minus 0.022 into 2x. It will become 0.044x. 44x. This is equation number 3. Equation number 3. This equation is called slope equation. Slope equation. In turn, slope is nothing but tan theta. Tan theta equal dy by dx. You just differentiate this equation, you are getting slope equation. So this is the second step. In second step, we computed rise and slope equation. Rise and slope equation. What is the third step? In third step, we are doing bending moment diagram. In third step, we are doing bending moment diagram. For this, we know that bending moment at A, bending moment at B, bending moment at C, 0. Because at 3 points we are having hinges. Right? Moment at A, moment at B equals 0. Because hinge. Okay? Now, I want to determine the moment between AC and I want to determine the moment between CB. Now, first I am considering between the portion AC. Here, I know the value of VA, 53.33 kilonewton. I know the value of H, 80 kilonewton, and I am having one more point load of 80 kilonewton from 10 meter from the hinge. 10 meter from the hinge. Now I want to determine, say this is A, B, C, to take this as D. Take this as D. Now I want to determine the moment at D. Where there is a point load, we want to determine the moment value. Because under that load we are getting maximum moments. So I want to compute EMD. I am considering left to right section. Therefore, clockwise positive, anti-clockwise negative. But the thing is, if you take this section, I don't know this value. This is YD, and I don't know this value. That is XD, but XD is, I know, 10 meter. X is 10 meter, but I don't know Y. Clear? So, if you write the equation, this is clockwise, 53.33 into 10, load into perpendicular distance, 10. This 80 rotating anti-clockwise, 80 into perpendicular distance is YD. For this 80, perpendicular distance is YD. Clear? It will not come because I am considering that particular point. Clear? So, in next step, MD equals 53.33 into 10 minus 80 multiplied by, what is YD? I know Y value. I want YD. At D, what is the X value? At D, X value is 10. At D, we know that at D, X equal 10 meters. Therefore, YD will become 0.667 into 10. X is 10 minus 0.22. X square is 10 square. x square is 10 square. We just solve this, we are getting MD value. What is the MD value?
175.7
Positive?
kilonewton meter.
Okay, 175.7
7 kilonewton meter.
kilonewton meters. We got MD. Now, in this section CB, we are not having any loads. If you are having any loads, you have to take the moment at point load points. If you are having UDL, you have to take at exactly mid of the section, because at mid of the section we are getting maximum bending moment. But in this case, we are not having any loading. In between CB, we are not having any loading. Hence, we have to locate the point of x distance where exactly maximum bending moment can occur. Therefore, consider the portion CB. Consider the portion CB. I know the value of BB. I know the value of H. I know the value of VB. Value of VB is 26.67. Value of H is 80. Value of H is 80. And I don't know where exactly maximum bending moment can occur. Therefore, I am considering the section x-axis. I am considering the section x-axis. Section x-axis. And I am treating this height as yx and this distance as xx or x. I don't know this distance where exactly x can happen. Clear? Therefore, now I am taking mxx. mxx is when you are considering the moment left to right, anti-clockwise moment, positive, clockwise moment, negative. Therefore, it will become minus 80 into yx. Minus 80 into yx. And this is anti-clockwise, right? Anti-clockwise, positive. And this is clockwise. This rotating in which direction? Anti-clockwise. This is rotating in clockwise, right? This is minus 80 yx. This is plus 26.67 into x. 26.67 into x. Now substitute y value, yx value. We are getting mxx equals minus 80 into 0.667 x minus 0.2022 x square plus 26.67 x. 26.67 x. For the maximum value of bending moment, we have to differentiate this equation. We are getting x value. The partial derivative of moment will give the x value. You take dou mxx by dou x equals 0 for maximum value. For maximum value. If you differentiate this equation, you are getting x value. What is the x value? If you differentiate this, you are getting x value. What is the x value?
7.51 meters.
7.51 meters. 7.51 meters. If you differentiate this equation, how to differentiate this equation? If you know that 0.667 into 1 minus 0.022 into 2x plus 26.67. Only x you are having unknown. Determine that x value. You are getting 7.51 meters. Now I got the distance 7.51 meters. Substitute this in mxx equation to get the moment. So if you substitute in mxx x value as 7.51, you are getting mxx value, right? 7.51 meters. What is the mxx value?
Minus 100.27.
Minus 100.27
27
kilonewton meter. Minus 100.27 kilonewton meter. Just substitute in this equation, you are getting mxx. Now we got the value of moment at D, the value of in between CB. Now we can plot the bending moment diagram easily. The next step is plotting of bending moment diagram. Plotting of bending moment diagram. Consider the three-hinged arch. This is A, this is B and C. Moment at A, moment at B and moment at C are 0. Here we are having 80 kilonewton, right? In this point we are having 80 kilonewton. So what is the moment at 80 kilonewton? 175.7 positive. If you are having positive value, plot above the arc, plot above the segment. So this is 175.7 kilonewton meter. Here because of point load, this is linear. This is not parabolic. This is a linear straight line. In between CB at 7.5 meters distance, we are having one more moment, that is negative moment. Plot below the segment. What is the value? 100.27 kilonewton meter. So you just come to 0 linearly. Once again there is no load. Come linearly and join to 0. This is negative, positive. This is the bending moment diagram. Bending moment diagram for symmetrical parabolic arch. For symmetrical parabolic arch. The next section is computation of normal thrust, radial shear at 12 meter from the left hinge. Computation of normal thrust and radial shear at 12 meter from the left hinge. For this calculation, it's a very simple calculation. From the left hinge, I will consider 12 meter length. This length is 12 meter. Within this 12 meter, the load 80 kilonewton will also cover because 80 kilonewton will act at 10 meters. Right? Clear? And we are having VA value. What is VA value? 53.33 kilonewton. We are having H value. What is the value of H? 80 kilonewton. 80 kilonewton. Now, this is the point I require the normal thrust and radial shear. We know the standard equation for normal thrust and radial shear. What is the equation for normal thrust?
H cos theta plus
H cos theta plus
V sin theta.
V sin theta. What is the equation for radial shear?
H sin theta
H sin theta
minus V cos theta.
minus V cos theta. Just observe over here, we require H value, we require theta value, we require V value for the computation of normal thrust as well as radial shear. The H value is known. This is H is same. H is 80 kilonewton. Now I want to determine V value, where V is shear force. Shear force. I require to compute shear force at 12 meter span. At 12 meter span. So plus 53.33 minus 80. V equals plus 53.33 minus 80. What is the value of V?
Minus 26.67.
Minus 26.67 kilonewton. So only summation of vertical forces covers 12 meter span. Because we are computing normal thrust and radial shear at 12 meter. We got H, we got V, we require theta. I know slope equation. When we are having slope equation, previously we computed. What is the value of tan theta? We know slope equation. Slope equation. I think equation number 3 or 4. 3. Equation number 3. Slope equation, equation number 3. Tan theta equals dy by dx equals how much?
0.667
0.667 minus
0.044
0.044
x.
x. Here, what is x? X is nothing but 12 meters. Substitute x value equal 12 meters. We are getting tan theta, tan inverse of 0.667 minus 0.044 into 12. If you do this, you are getting theta value. What is the theta value?
7.91 degree.
Theta value equals 7.91
91 degrees.
degrees. Now I got theta value also. We know h, we know v, we know theta. Substitute all the values in this equation. We are getting normal thrust and radial shear. What is the value of normal thrust?
75.56 kilonewton.
75.56 kilonewton. What is the value of radial shear?
31.42 kilonewton.
31.42
Kilonewton.
kilonewton. So it's a simple problem. It covers a single point load when given in symmetrical parabolic arch. In previous problem we covered the arch considering with respect to point load as well as uniformly distributed load. I hope you are understanding in the easiest manner. In first step we computed external support reactions. In second step we computed rise and slope equations. In third step, with the help of rise and slope equations, we computed bending moment diagrams at each sections. In last step, well, depending on the given problem, we determined normal thrust and radial shear. Thank you.